In this video, we are going to go over section 8.1 and 8.2. 8.1, we are going to go over right triangle trigonometry. 8.2, we are going to add trigonometric functions, so sine, cosine, tangent, and basic function. So both 8.1 and 8.2 is a review concept from trigonometry because we are going to be working on derivatives and integral of the trigonometric function in 8.3 and 8.4. So 8.1, 8.2 kind of wanted to give you a short review of basic concept involving the right triangle. The actual calculus material will be 8.3 and 8.4. So this video will be very quick, and then mostly you're going to be recalling a lot of information because it's basically coming from trig class. Okay, so there are two ways widely used measure of angles in trigonometry. One of them is degree measure in degrees, and then we have a radians measure. So we can go back and forth between a degree and then radians. 1 degree is equal to pi radian over 180. In other words, 1 radian is equivalent to 180 degrees divided by pi. So let me give you a little bit of an explanation, the difference between the degree measurement and the radians measurement. When central angle of a circle is subtended by an arc that is 1 over 360, the circumference of a circle, the angle is said to have a 1 degree measure, or we simply use 1 with the little circle. So whole complete circle will represent 360 degrees. So it will make up those 360 degree. On the other hand, the other measure of the angle is radian measure. The central angle subtended by an arc of a length equal to the radius. So this is measured as a equal distance to radius of the circle, is to have a radian measure of 1, and we write it as a 1 rad. Definition, trigonometric function, you should recall this one. Sine is opposite over hypotenuse of the right triangle. So you can definitely draw a right triangle, and then let's say you call this x, or sometimes we measure theta, right? Then sine will be whatever the x is. We have an opposite over hypotenuse. So the side that is opposite from x, and then we call this side opposite of a 90 degrees hypotenuse. And then the bottom piece, we call it adjacent side. So you can basically derive all 6 trigonometric functions from this right triangle. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Secant is hypotenuse over adjacent. Cosecant is hypotenuse over the opposite. Also, I'm going to draw 2 triangle, the one with the 30, 60, 90 degree and 45, 45, 90 degrees. We call those a comment the known angle triangle, and then we will be using that a lot without a calculator. So recall the 2 measure one, one of them is the 30, 60, and the 90 degree, has the side length of root 3 on the bottom, 1 and 2. And then the 45, 45, 90, 45, 45 degree 90 angle has 1, 1 root 2 length. Okay, so let's get on and then review some basic concept of the right triangle. Problem 1 and 2 begins with converting the degree into a measure, radians measurement, and then 3 and 4 is the opposite. We start with the radians, and then we want to convert it to degree. So we have the formula here. the 1 radian is equal to pi rad divided by 180. So that will be your conversion factor. So let's try this one. So we start with 240 degree. That is equal to 240 degree over 1 times pi over 180. We use this conversion factor to multiply. So you can also put radian here as a unit. And then degree here. So notice that degrees cancel out because they're on the opposite side, right? And then you can reduce, let's see, 180 goes, both of them can be divisible by, let's see, so they're both even number. They're both divisible by 60. So let's reduce. 60 goes into 3 times, goes here 4. So final answer, we get 4 pi over 3 radians. So 240 degrees is same thing as 4 pi over 3 radians. You can also have an angle in negative measurement. Let's also change that into a radian mode. Same thing, we begin with what we are given, multiply by the conversion factor pi radian over 180. I know that one way, which one do we have to use? Well, this is how I remember. In order for degree to cancel out so that we are having a radian, I need to have these opposite sides. So I know that degree has to be on the bottom. 135. Let's see. So both of them is divisible by 5. So 135 is divisible by 5 by 27. So 527. And then 180 is also divisible by 5 by 36. It looks like they are divisible further, both by 9. 9 goes 27 3 times, 9 goes 36 4 times. So final answer, negative, don't forget the negative, negative 3 pi over 4 radian. Okay. Now let's work backward, 3 and 4. So your conversion factor is flipped. Your conversion factor is 180 degree and then pi on the bottom. So we have pi over 10 times, we want to convert it. So my conversion factor is 180 degrees over pi. Pi's cancel out. 180 goes here how many times? 18 times. So 18 degree. Okay. Same thing, negative 3 pi over 4 times. We have conversion factor 180 degrees over pi. Pi's cancel out. Let's see. I have 180 divided by 4 goes perfectly by 45 times. So negative 3 times 45 will give me negative 135. Okay. So the first page, being comfortable with both degree and then the radian mode and then converting between back and forth. Next section, let's find the function value, the trig function value. 5 through 7 ask you to have an exact value. That means no rounded answer. Okay, no decimal answer. You want to leave it as a radical form or the fraction form. 8 through 10, you can use a calculator to find the value. So if you look at 5, 6, 7, exact values are those common angles, 30s, 60, 90s, 45. Also, something like 120 is also a fair question because 120 you can use a reference angle of 60. Okay. So let's start with the 30 degree. So I know that I have a sine of 30 degree. So going back, I will be using this triangle because it's a 30 degree. Okay. And then I'm going to actually, let me actually copy both triangle here. And then put it over here. So you guys can see this triangle. And then we know that sine of 30, sine is opposite over hypotenuse. So the angle is a 30. So sine of 30 is opposite over hypotenuse. So you're standing right over here at 30. Opposite will be 1. And then hypotenuse will be 2. So you have 1 over 2. Okay. And that's it. That's it. Sine 30. Secant. Let's recall secant. Secant is hypotenuse over adjacent. So let me use a different color so you guys don't get confused. Secant of 45 is, again, hypotenuse over adjacent. So write it down. Hypotenuse over adjacent. Now I'm standing at 45 degree because I want to know secant of 45. Hypotenuse is root 2. Adjacent will be 1. So it will be just root 2. Okay. The earlier one, it was a half. Same thing, cosine 60. Cosine 60, now I am standing here because it's at 60 degree. Cosine is defined as adjacent over hypotenuse. So we write it over here, adjacent over hypotenuse. And then adjacent will be closed side 1, and then hypotenuse is 2. So I have 1 over 2 as the final answer. Okay, and you leave it like this because they want exact value. Now, on the other hand, 8, 9, and 10, these are not a known angle, not a friendly angle, because take a look at the 73. We don't have a 73 triangle as a nice one. So we are going to be using the calculator. Now, in here, you have to be careful when you're using a calculator because your calculator doesn't know if your angle will be in radians or degree mode. They're gonna give you wrong answer if you put 73 and then in radian mode, and then if you put like 1.5 and then degree mode. Okay, so you have to be careful. Also, part of your value, when you find the answer, they want you to round it to the 4 decimal places. So let's begin with first one, 73. Now, how do you know which one is which? Well, it tells you here. You see the degree symbol. So this is the degree mode. None of these do not have any symbol attached. So this will be the radian mode. Radian mode. It's also nice to write it on the side so you know which mode you need to switch. So let's begin with first one, tangent of 73 degrees. Okay, so you pull out the calculator. I have it over here. Oops. Okay. Let me, second plus 7, 1, 2. Okay. Reset it. So one way they have right over here mode symbol right next to the second key on the right, second row, right? Next to the second key there's a mode. Normally your calculator will set it as a radian right there, right? You see the radian. You can switch back and forth by just simply enter. The first one was degree, so you put degree. And then press second mode to go to a home screen function. And tangent, you have all these sine, cosine, tangent symbol right over here on the middle row of the calculator. So first one was tangent 73 and close it. You don't have to put the degree symbol because we already have the mode into degrees, so they will know. Enter that. The final answer is 3 point. They want you to round it to the 4 decimal place, so 3.2709 will be my final answer. Right over here, 3.2709. Okay. Now the next one, sine of 1.5, radian mode. Do not always begin checking because you never know what you ended your last problem. So change to radian. Okay, and then second mode to go to quit, and then it was a sine 1.5. Enter. So 4 decimal place again. So you have 0.9975. 0.9975. Last one, secant. Now, unfortunately, your calculator the calculator only have a sine, cosine, tangent because they want to minimize number of buttons on the calculator. But what is relationship between these cotangent, secant, and then cosecant? Take a look at this. Sine is opposite over hypotenuse. Secant is reciprocal of it, right? Instead of opposite over hypotenuse, you have a hypotenuse over adjacent. So even though you do not have a sine secant on the calculator, you know that this is same thing as 1 over sine x. Reciprocal function, so they are reciprocal of each other. Tangent and cotangent is a reciprocal function because you see the opposite adjacent and adjacent opposite. So if you are given a cotangent, you can use 1 over tangent of x on the calculator. So therefore, the last pair is the cosine and cosecant. So cosecant is 1 over cosine of x. So we'll do that. So in other words, secant, you can rewrite the secant as 1 over cosine of 1.1 in radian mode. That's what I'm going to do. So you have 1 divided by, since it's a fraction, just be careful, put extra parentheses, and then cosine of 1.1. We already ended our last problem as a radians, so you don't have to change it, but double check. Yes, it is in radian mode. Okay, and then enter. So your final answer rounded to the 4 decimal place, 2.2046. 2.2046. So that will be our final answer. Okay, again, quick review. Let's move on to the last 2 problem of the section. Problem 11 and 12. Use the given information to solve the triangle. Round angles to the nearest degree and side length to the decimal. So the whole number for the angle, and then for the side, we are going to have a 1 decimal place. So here, we are given a triangle with some information, and we need to find some missing things, right? So we are given angle B, okay? And then we are dealing with all right triangle in this class. So we'll assume that one of them is 90. So we draw a triangle. Let's label just this one as A, B, and C. Okay. And then B is 29 degrees. And then so that will be side. Let's also label this side opposite from angle A. We'll call it A. Side opposite from angle B. we call it B, and then C for the hypotenuse. So I'm going to label this with the information. So C will be 90, B will be 29 degrees, and we are given a length that is opposite, so 13.5. So we have to find the missing side in angles. So you know by geometry, A will be what? Interior angle of all triangle is 180. So you know that A plus B plus C equal 180. We know B is 29 degrees, C is 90 degrees. So we can find the missing angle. So 29 or add 90, we have 119, 180. So angle A will be whole number 180 minus 119, 61 degree. Okay, so that's one of the answer, angle A. We found the angle. So let's add that. So 61. Okay, and this and then also technically we let angle C as 90 degree, right? Okay, so 60 and then C 90 degree. So those we found. So let's also find the missing piece. Now we have to use a trig function. Remember sine, cosine, tangent? So let's start setting up. I am given this side opposite of B. So that is opposite. And then you can choose either function. Let's say we want to begin solving for C. Then you can set up sine over 29 degree will be opposite over hypotenuse. So 13.5 over C. Okay, so sine of 29 is 13.5 over C. Now sine of 29, we're going to be using a calculator because that's an unknown angle. So let's pull out the calculator and notice it's a degree. So I have to change my mode to a degree. And let's enter sine of, it was 29. That end up being 0.4848. I'll just round it to the 4 decimal place. So this will be 0.4848. 13.5 over C. Now in order to solve for C, I'm going to be using a cross multiplication. So 0.4848C, 13.5 divided by 0.4848, 0.4848. C is equal to, I end up getting 13.5 divided by 0.4848. So they want you to round it to the nearest 1 decimal place, so 27.8. 27.8. So this one over here will be 27.8. And then I'll just highlight this because this is something that I found. Now we have one last one, A, side A to we have to find side A. Now you can choose 29 and then set up, or you can use 61. You have two choices. You're gonna get exactly the same. Okay, I'm going to create more space. Let's resize it. Also going to resize this one. Okay, and then let's set up A. So A, if I use sine of 29, this one A, it will be this one, I'm sorry, should not be sine anymore because A will be the adjacent. So you can choose either one. So you will have opposite over adjacent. If you set opposite over adjacent, then I'm going to use tangent function. So tangent of 29 degrees will give me opposite over adjacent, so it will be 13.5 over adjacent A. You can use 61 or you can use a cosine of 29 degrees and use 13.5 and 27.8. You're gonna get the same answer. So you can verify, check. Okay, so let me make a quick note. Verify. If you set up cosine of 29 of third adjacent over hypotenuse 27.8. Also you can set up opposite, so cosine sine of 61 degree opposite over hypotenuse. You can also do that. A over 27.8. You're gonna get both same answer as this. So you have lots of choices, but I'll just stick to the original one. So I have tangent of 29 degree equal 13.5 over A. So I'm going to end up having a I will set up cross multiply. So I have a tangent of 29 degrees times A. And then we have 13.5. In order to have A by itself, I would divide it by tangent of 29 degrees. So A will end up having, so we put directly on the calculator, make sure it's in degree mode. It is already in degree. So we put in, oops, let me go back, 13.5 divided by tangent of 29 degree. That will give me 24.4. So A will be 24.4. Okay, so that's it. Okay. All right, so number 12 will be very similar. Instead, this time you are given an angle 47 degree and then side opposite B 17.8. You know angle C will be a 90 degree. So 12 is try on your own problem. Try on your okay, and then verify that everything works. But it's exact same things, very similar, and you're going to end up having lots of choices to find the missing piece. All right, I'm going to jump right onto 8.2 because it's a very short chapter and also another review. So it will be just one combined video of a review concept. Now we are going to go a little bit more in depth in 8.2, and then we are going to add more periodic graph. So sine, cosine function with real number domain. So we are adding the domain too. Also sine, you can also leave it as a sine of radians. Cosine is also cosine. Now tangent, one way to express tangent is you can rewrite tangent as a sine over cosine function. So recall that. This one I kind of mentioned that. Secant will be the reciprocal of a cosine. Cotangent will be reciprocal function of tangent. So if it's a sine over cosine, you will have it flipped. So cosine over sine. And then cosecant x will be 1 over sine of x. Okay? And we are going to play with, again, common angles 30, 60, 90, or also in radian mode, pi over 6, pi over 3, pi over 4. And then also some coordinate points, right? At the 0, 90, 270, and then 360. Okay? So let's add a little bit more. 1 through 5, find the exact value. So we are going to be working on triangle, just like earlier chapter. And then 6 through 9, excuse me. So I should change this one to 9. You're going to be using a calculator to get these numbers. So we'll also play with that. And then the last problem, I pick out some homework problems as well. Okay. So let's go back and then start with the exact value of the function. So cosine of 7 pi over 4. So let's recall what is, so common angle is, so let's recall, so we have 30, 60, and then the 45 triangle given from the last part. So 30 degree is equivalent to, in the radian mode, it will be pi over 6. And then you can, this one I already memorized it because it's very known angle, but you can also do conversion factor. But you should also know that 60 is corresponding to pi over 3 radian and 45 is the pi over 4. So again, I'm going to copy this triangle from last section and then just add it here so it's all ready to go. I'll just add it right over here. In fact, let's resize this one a little bit. And then let's put it over here. Let's expand it a little. Okay. And I'm just gonna color code it. So 30 is pi over 6. 60 will be pi over 3, 45 will be pi over 4. So these are my triangle. So another thing I want you to recall from trig function is quadrant. This is how I remember all students take calculus. So all trig function in the first quadrant angles are positive. Only signs are positive in the second quadrant. Third quadrant only tangent, and then the last quadrant the cosine functions are positive. So for example, 7 pi over 4, we will use pi over 4 reference angle. So note that the reference angle is pi over 4, 45 degree. And then the terminal side, so where does it end? So 7 pi over 4, that is in quadrant, so 7 pi over 4, that is in quadrant 4. So this is in quadrant 4. Because you know that 8 pi over 4 is 2 pi, so also 0 pi over 2, right? Pi, and then 3 pi over 2, and then also 2 pi. So it's almost to 360, so it's in quadrant 4. If you have hard time imagining, then do a side work. Do a quickly, we review this in 8.1, just change to degree and see which degree it is. So you do pi 180, pi's cancel out. 180 divided by 4 will be 45. 45 times 7 is 315. Indeed, it's in fourth quadrant. 315 is somewhere here. So I'm going to end up having positive answer. These are something that I like to write down on the side, so I know that my final answer, I'm going to have a positive angle, and then my reference triangle will be 45 degrees. So I don't jump right onto the problem. I do all these side work to set up the problem. So you should do the same thing too. So now we are ready. So by 45 degree, I know that it's 1 root 2, and then it's a cosine. So I'm going to have a cosine of 7 pi over 4. Positive answer because it's in quadrant 4. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse, so 1 over root 2. Or if you, this is perfectly fine. Some likes to rationalize, so root 2 over 2 is also fine. Okay. So let's do another one. So sine 5 pi over 3. My reference angle is pi over 3, which is 60-degree triangle. So I draw myself 30, 60, 90. Okay, 1, 2, root 3. And then I'm standing over here, and it's a sine. Now 5 pi over 3, again, we have to decide where is 5 pi over 3. You can, if you feel comfortable looking at angles in a radian mode, that's fine. If you still don't feel comfortable, there's no need to guess. Just convert it to a decimal and see where it lands. So 3 goes into 80, 60 times. 5 times 60 is 300 degrees. So you know that 270 is right over here. So 300 is quadrant 4. Now in quadrant 4, only cosine is positive. So I'm going to have a negative answer. So this is how I set up, right? Sine. So sine of 5 pi over 3 should be negative. And then what is it? Opposite. So opposite over hypotenuse, root 3 over 2. So negative root 3 over 2 will be my final answer. Keep going. This is a negative angle, and this is a degree mode. So 135, the reference angle will be 45 degree. Now this is going in a negative direction. So negative 135 will be, where does it end? It will be not necessarily going into all the way up to 180. So negative angles goes in clockwise. So it will land in quadrant 3. Now quadrant 3, sine is negative value. So triangle of 45 will be 1 root 2. Sine of negative 135 degree will be opposite over hypotenuse. So negative 1 over root 2, or negative root 2 over 2 will be also fine. Okay, so that's how we set up and then use the triangle to get the answer. Let's try a couple more. Now going into positive direction, 135 is right over here. So this is quadrant 2. So cosine is negative here because only sine is positive. So I have a reference angle, same thing. I can use 45 degree. So I'm going to use the same one over here. Cosine of 135 is a negative. Cosine is adjacent over hypotenuse. So if you're standing here, adjacent over hypotenuse, 1 over root 2 or negative root 2 over 2. Finally, last one, cosine of negative 60 will be in quadrant 4. It's a positive function. This is already reference angle of 60. So 30, 60. So 30, 60 has a root 3, 1, 2. Right over here is the 60. So cosine of negative 60 is a positive answer. Cosine is adjacent over hypotenuse. So I have positive half as the final answer. Okay. 6, 7, 8, 9 is more using a calculator because these are not in a known angle, not reference angle. So again, we'll play with the calculator. Be careful which mode you begin with, right? So we get the correct value. So the first one is tangent 172. Now you can see that that's a degree because you have a degree symbol. So let's make sure that we have a degree mode to start. So mode, yes, we are in degree right there. Let me erase. So first one was a tangent of 172, just very simple, very easy. You get the answer right away. Negative 0.1402. So change to, rounded to the 4 decimal place, negative 0.1405. So the degree mode, we get negative 0.1405. Rounded to the 4 decimal place. That makes sense. 170 degree is right over here before 180. And then only the sign is positive, so I should have a negative answer. Second one is, you can see that this is a radian mode. Same thing, number 8 radian. And then this one is a degree mode. So let's do, I'm just gonna do everything into a calculator and just copy down. So 7 is cosine negative 1.82. Now secant, we did not have a calculator function, so I'm gonna put 1 over secant is a reciprocal function of cosine. Okay, so that's what I'm gonna put. Okay, so let's begin with a 7 and then 8, 9. Gonna do it everything 1 so you can see the answer. So number 2 was a radian mode. So cosine negative 1.82, that was second one. So that's my answer right over here. Okay. Cosine negative 1.82. And then next one was a secant one. So the secant was 1 over cosine of 7 pi over 8. Close parentheses. So I have negative 1.0824. And then the last one was cosine of negative 28 degrees. So we change mode back to a degree. And then put cosine of negative 28. Negative 28. Okay, so there you go. So number second one should be negative 0.24. Let me write it on the side. Negative 0.2466. The third one should be negative 1.0824, rounded to the 4 decimal place. Last one should be 0.8829. Okay? So very simple, quick, and easy with the calculator. Just be careful, change to the appropriate mode. So 7, we got negative 0.2466. We got this one, negative 1.0824, and then final answer is 0.8229. Okay. The last two comes from the homework problem. So they want you to use a graphing calculator and then graph the function. Okay, so let's see how to use graphing calculator to graph the function. So zooming in. So this whole thing looks very complicated, but this one is my entire function. They given a domain and range value. The domain is from 0 to 8. 0 to 8, that's your x value, and then y value is -1 to 7. So I'm going to be putting this into a calculator. I'm gonna put everything in 1. And then notice that set the calculator in radian mode because pi over 2 is in radiant. So this is how you change the setup of a calculator to graph. So let's pull out the calculator. Make sure you begin with the correct mode, which is a radian. Change that. Y equal to and write the function. It was 3 minus 3 cosine. And then we had pi x over 2. Now, don't graph it right away because they give you x and y values. So go to a window. It's the first row of a button. The second column, it says window. Normally, it's going to set up as these number, -10 to 10. But we want to change that. They give you particular... Oops. Oh, it got deleted. So, oops. For some reason, I exited out. So let's just redo it. Cosine mode. Make sure it's in radian. Another review is not gonna hurt. So 3 minus 3 cosine. It was a pi x over 2. Okay. Delete. Okay. Too much parentheses. Let me begin. 3 minus 3 cosine pi 2x over 2. There you go. And then window, it was given as a 0, so change to 0. And this is how you change these range and domains, 8. And then leave x scale as a 1 because all we are given is just the x values. And then y value was a -1 to 7. And then that's how you change the domain and range and graph. So this is the graph that we are looking at. So I'm going to screenshot this one so that I can make a side comparison to choose the correct answer. So we have answer A through H. Here's the screenshot of what we got from the graphing calculator. Okay, so looks like the best answer matching out of all the choices that we have looks to me B is the correct one. B looks pretty much similar to what we have over here. E. Okay, so that's how you use a graphing calculator. So same thing. Let's try this one. Here, suppose the profit of a sale swimming suit in a department store over 2-year period are given approximately by, here's the function. And then where P represent the profit, and then T represent the weeks, and then they give you the graph here. Part A, they want you to find exact value without a calculator, and part B, you use a calculator. This sounds very familiar. We did find the exact value, so that has to do with some known angle, and then we use a calculator, so it's very similar. So this is just a repeat. So here I'm only gonna do the very first one, and then remaining one you can try on your own. So let's try one without the using a calculator. So that means I need to take the input of 13 and plug it in over here. So let's write it out. So that will be, my input is 13 for t, so 5 minus 5 cosine pi. T will be 13 now over 26. Let's simplify. 13 goes into 26. How many times? Twice. So that simplifies to 5 times 5 cosine pi over 2. And pi over 2 is a 90 degree. That's a quadrant angle right over here. 0, 1. And let's recall from the trig class, the quadrant angle, the cosine is your x value. So cosine at 90 is 0. So I have 5 minus 0, which is equal to 5. We did it without using a calculator. So you're going to do the same thing with, so that means these numbers will end up canceling out nicely, and the angle there will be something that is known angle, so you can easily compute the numbers. Now let's do one with the calculator. They want you to round your answer to 3 decimal place. Same thing, replace with 37 for t. 5 minus 5 cosine pi. T will be 37 over 26, and you can see that it doesn't cancel out nicely. So this is the one that requires calculator. So let's put the whole thing into a calculator, round it to the 3 decimal place. Pull out the calculator. This one is, be careful, always begin with which mode. It will be radian because it's a pi. You don't see a degree. So it has to be a radian mode, which is good. And then just type it in the whole thing. 5 minus 5 cosine. And then on the numerator, it was 37 pi. On the denominator, it was 26. Close the parentheses. And then rounding to the 3 decimal place, I get 6.197. 6.197 as the final answer, rounding to the 3 decimal place. Okay. So you'll do the same thing for the second part. All right, that's it for section 8.1, 8.2. All these concept is nothing new. It's a review. So we went over pretty quickly. Please review the concept of trig functions, because 8.3 and 8.4, we are going to add the calculus part, okay, which is derivative and antiderivative. So it's really important that you know all these trig functions. Okay, I will see you guys in 8.3 videos.